Right, in this next video in our series on the vector equation of a line, we're going to look at how we can find out where two lines intersect once we've found the vector equation of the two lines. So the first thing to do is to find the vector equation joining these 2 points and find the vector equation joining these 2 points. So we need to find, remember, how to get from the origin to the line. That's our vector A, and we also need to find a direction vector B in the line. So for our first line, L1, we can find the direction vector by subtracting the two positions from each other, and we get 5, 0, 1. And we can pick a point in the line. Let's say pick this one here, 3, 2, 4. So L1 will be R equals 3, 2, 4, how to get to the line, plus lambda lots of 5, 0, 1. So let's do the second line. So for L2, we're going to subtract the two vectors. So let's do 8, 2, 5 minus 1, 0, minus 1. And that gives us 7, 2, and 6. 5 minus 1 is 6. So that gives us our direction vector. And we're going to pick the 1, 0, minus 1 to be a point on the line. So R will equal 1, 0, minus 1 plus, we're going to call it mu. Remember, always use a different parameter when trying to look at two vector equations. You must make sure the parameters are different. And we get 7, 2, 6 in this case. So now we're going to work out where these two things cross. So we've got line 1 and we've got line 2, and we need to solve where these two cross. So what we need to do is remember that R is effectively equal to x, y, z. To find where these points cross, we must find the x, y, z. So we're going to take the 3, 2, 4 plus lambda 5, 0, 1, which equals the x, y, z, and it must equal the x, y, z of line 2, 1, 0, minus 1, plus mu lots of 7, 2, 6. That's what the x, y, z of this vector line will equal. And then we realise the top row just gives us the x coordinate, the middle row gives us the y coordinate, and the bottom row gives us the z coordinate. So therefore 3 plus 5 lambda equals 1 plus 7 mu. 3 plus 5 times lambda equals 1 plus 7 times mu. And then we go to the middle row for the y values. 2 plus 0, lots of lambda, equals 0 plus 2 mu. That makes finding mu very easy. Let's just put the bottom row in. 4 plus lambda equals minus 1 plus 6 mu. So this just implies that mu equals 1. So let's put mu equals 1 into here. If we let mu equal 1, this implies that 4 plus lambda will equal minus 1 plus 6. So therefore lambda will equal 5 minus 4 is 1 as well. So we now see that this works for this, it works for this, so we check in here. So we put lambda mu equals 1 and lambda equals 1 into that. So therefore we've got 3 plus 5 times 1 equals 1 plus 7 times 1. This is right. Yep, cross tick, which is it. So we get 8 equals 8, which is true. So therefore the two lines intersect because the mu and lambdas, once you've found them from these two, agree in the third equation, and they intersect where lambda or mu equals 1. So the point of intersection you can put back in. This gives your x coordinate, your y coordinate, your z coordinate. So therefore put lambda equals 1 into here, and you get therefore the point of intersection is 3 plus 5 is 8, 2, and 4 plus 1 is 5. We can just check on the other side for the other equation. 1 plus 7 is 8, 2 times 1 is 2, and minus 1 plus 6 times 1, so that's 6, minus 1 gives you 5. So here is our point of intersection.